Welcome back. In this video, we'll map out our approach to solving the asset problem. That is, getting our hands on the sprites, backgrounds, music, sounds, maps, and any other components we need to construct our prototype. We'll explore the file structure of Traffic Department and consider an approach to extracting assets. Finally, I'll show you the tools that we'll use during this process. Now, in game development, there are two general solutions to the asset problem. We can make the assets with a team of talented artists, or we can take the assets from another source, such as licensing or a community repository. Making original assets may be the most time-consuming and expensive part of game development, so we're going to focus on taking the assets out already buried in the original game files. Don't worry if breaking apart files sounds difficult. Games of this era weren't designed with security or obfuscation in mind. We can use common sense and experience to make educated guesses about the structure of the archives. We'll then use those guesses to make small programs to pull out the data. Now, having access to final assets before prototyping means that we've shaved off at least half of the total development time. And then prototyping with a commercial engine shaves off the other half. A key point of this project is to show that recreating classic games has been reduced to single-day projects with no budget, thanks to all the hard work put in to free tools like those we're going to use today. Now we'll look at the files in the Creative Commons release of Traffic Department that we played through in the last video. In fact, let me create another shortcut for that, since we'll be jumping there a lot. I'll open PowerShell just in case we want to take a closer look at anything. Now, in the folder, we see that there are over 200 files. It's a safe bet that each type corresponds to a specific asset. If we're lucky, each file is only a single asset. We'll attack these files by type and figure out what kind of asset they store, what format they're in, and how we can turn them into a more common format, such as transforming all graphics into bitmaps. Alright, sorting by type, we see several application binaries at the top. In the last video, I started the game with this binary, td1.exe. This is the first episode and only contains missions 1 through 20. Episodes 2 and 3 must be started with these alternate binaries. The others appear to be support programs. We can make an educated guess about their nature from the title, such as aboutus.exe. Alright, scrolling through, I'll shout out what I see as I see it. BLK, don't know, I assume it's a graphics asset. CCM, still no idea, it could be graphics, could be music. There's one for each episode. Alright, CFG is probably a text configuration file. tdlet.cin is probably a font or a character set, just guessing by the cin extension. CMF is definitely music. It's a Creative music file. Creative Labs supported this file with their Sound Blaster cards in the 90s. CMM, maybe also music. I think it's another Creative Labs format. It may be short for multimedia. Alright, DAT files, it's usually arbitrary data, possibly text, or probably text considering it says dialogue. Let's check over here in PowerShell. There's dialogue for the first mission that we played in the first video. We'll definitely be using these. Alright, there's the script for the whole game. If you do this on your side, you'll hear annoying beeps because the console is processing the ASCII control code for Bell. I believe that's hex 0B. We'll take a closer look at this file in a couple videos. And the safe dialog as well. Alright, a whole bunch of I don't know file types here. EXP, FAC, H2, HEL. I'm going to assume these are sprite graphics of some kind. We'll have to figure it out later with a text editor. Alright, LT2 and LTR, these might also be fonts with the extension meaning letter. I know we saw that CIN file earlier and also tied that to fonts. Alright, map files, I think we can guess what these are. Either the actual map data or embedded sprite sheets for the maps. They all appear to be the same size. Alright, some text files. Alright, PAL files. I bet these are default palettes. Remember we noted palette artifacts in the playthrough from the last video. It says 1K size, but let's get a specific value. Both are 768 bytes. That's a good indicator that this game uses 256 colors, and these files hold the lookup values for all 3 color channels. So 256 red values, 256 green values, and 256 blue values. That comes to 768. Good to know when we open up the graphics files and we don't end up finding actual RGB pixel values inside, just arbitrary bytes pointing to these palettes. All right, moving on. Okay, PIC files, probably graphics. PIC is a known file format in this era, although these files may not be that. They're still probably graphics, though they're all different sizes. And we see a screen full of files labeled screensaver. They aren't actually screensavers, but they have the .scr extension that Windows assumes is a screensaver. We can't actually run them like that. Notice the intro and hanger files. Judging by names, I bet these are those static screens to those graphics. They all say 64K, so let's check the actual file size. All files are exactly the same size. I think we'll probably go after these files first since there's so many of them, and it should be easy to figure out how the fixed size format is put together. If these are custom formats, then we can hopefully pick up some insight as to how developers pack the files, and we can use that insight to build up more complex asset types. Moving on, a few more singleton file types. Again, I'll assume that these are graphics of some kind. Now we have a number of TD files. That might just be a generic extension. Here's a list of files named M followed by numbers from 1 to 20. These are probably the mission definitions, maybe setup scripts or something of that nature. They'll likely be very game dependent and could be very difficult to figure out. I usually save these kind of files for last. Alright, a new faces.td, fairly sizable. I'm betting those are the face graphics we saw in the dialogue sequences, just by the name. Uh-oh, now we see the exact same files, but with .td2 extensions. These must be for the second episode. Let's see if there's a TD3, and there is. I also see the new faces.td2 and new faces.td3. I think we know where this is going. Right, at this point, I'm only guessing that these new face files contain the graphics for the character faces. If it turns out to be true, then we might wonder where the old faces file are, or just the faces file. My guess is that this game was originally designed with quick and dirty faces as concept art, and then the designer came back with these files later named new faces, and it stuck. At the bottom, I see a lot of VOC files, another common sound effect type at the time. We end with a few more singleton types, WEA and WIN. We'll tear those apart later. Now, I wish I could say there was a guaranteed method to extracting assets. There isn't, and it really comes down to using knowledge and experience and a lot of trial and error. Observe the files, make a guess, test it out, revise if needed. It's the scientific method, really. The best way to prepare is to try to answer basic questions about what we're looking at. For instance, is the archive a well-known file type? We can use extensions, but sometimes these change or can have multiple meanings. We can also look at the first 100 or so bytes of the file to see if there's a header. Headers contain metadata describing certain aspects of the file. Well-known file types can usually be processed by just following the steps directed by the file designer. If it's not well known, then it may be a custom format, and we should continue to ask more questions, such as, is the file encrypted? This is usually obvious right away because the file will be very messy with no discernible structure. The byte data will have high entropy. That is to say, most of the bytes will value from 00 to FF, and they'll be represented evenly. Encrypted files require a separate approach, but I'll say up front, we're not going to see that here. All right, is the file encoded? Okay, that's a trick question. All files are encoded. Our job here is to understand the encoding and translate it to a format we can use, if we can't just use it directly. And we're going to try to use as many files as possible in their native format here from the archive. A better question to ask is the file packed? Can we determine if the file has a single asset, or multiple assets of the same type, or multiple assets of different types? A good example of that last case is the old Sierra adventure games like King's Quest and Space Quest, which all have game assets packed into files called resource.001 or resource.002. Do we know the format of the data? For instance, graphical data could be stored in raster format, such as pixel quality values, or it could be in vector data format, which is essentially instructions for reproducing the graphic. Sound files have a similar question. Is it raw sound data, such as a PCM encoded audio chunk, or is it simply settings to simulate a certain sound, such as a MIDI file? All right, what is the structure of the file? This can be broken down in multiple ways, but the simplest related question we can answer is the file fixed size format? Like the SCR files we identified earlier appear to all be the exact same size. Now, fixed format files mean that we only have to learn the structure of the file once, and we can be certain that it translates to all of the files. For instance, if we can assume the 500th byte of one SCR file has the same meaning as the 500th byte of another SCR file. That's why I wanted to start with this file type first. They all have the same size, and we have many of them we can compare. In analyzing a file, we want to identify possible structures, and if we have multiple files, we want to be on the lookout for breaks and changes in byte values and trends that exist among all of them. Alright, I think I'm done talking your ear off with this. The best way to build Instinct is to just do it, and we will, starting in the next video. My final points in this video are the tools we'll use. Now, I focused on free tools. I don't think it's worth it to invest in professional software for simple personal projects like this. For the most part, free alternatives can perform just as well as a professional toolset if used in the right hands. We'll rely mostly on a lightweight hex editor to analyze the files. Now, I've chosen HXD because it's intuitive and has a couple of helpful features such as byte count statistics, variable width views, and multiple offset base choices. For converting assets, I'll be using Notepad++ and the Minimalist GNU-C compiler to make small programs for each file type. Since I'm on a Windows machine, this will be the 32-bit MinGW. I'll also use SDL bindings for C, so be sure to have access to that library. Other than that, the C standard library is more than sufficient for basic file access and manipulation. We'll be using Windows PowerShell for basic OS console work, as you've already seen. There might be a case or two for using a spreadsheet program, so I'll use Excel. Excel isn't free, but I don't think it'll be mandatory for this project either. For image analysis, I'll use GIMP, which is a free open source analog of Photoshop. Finally, I'll be using a disassembler for looking at the game's binary files. Now, I've chosen IDA Pro, which is free if we use a version that's about 5 years old. Since we're dealing with a game that's 25 years old, it should easily be able to handle this. A disassembler is useful because it provides easy visualization of binary files, and we'll need to extract some of the hard-coded static data anyway. It's also useful to understand how the original binary files handle the assets that we're trying to extract. Now again, we won't be trying to reconstruct any specific source code. Finally, I've created a separate workspace folder that I'll copy assets to from the game directory as we work on them. I think that covers all the points I wanted to make. I'll see you in the next video where we'll stop talking and start working.